No. Somebody other than William.
KE equals 1/2 pound mass times volume.
All right, so on your formula sheet, it writes it this way. All right, does anybody remember how I changed it? Logan can't answer either. How did I alter the formula? What did I do to it to change it? Jacob, you belong up here. All right, how did I alter the formula? Logan and William cannot answer. All right. So Anna Lucia says I changed it to this. All right. I put the 1/2 over 2 because it makes it easier for us to cross multiply and solve for either the m or the v squared, which is true because it's easier for us to figure out how to cross multiply. Okay. Now, what was the other formula that we had? What's the other formula? Look at your orange card. Anybody out there in student land?
No. Ever.
All right, Sacramento has his out. What's the other formula? You can just read it off the sheet. Okay, PE equals MGH, and what does it say right after that? Okay? Now, how many formulas did we say that was last week? 2. Okay? PE equals MGH, or what's the other formula we get out of that? Jacob, hush. What's the other formula we get? Mr. East, you remember? Eh? Why? If I cover this up, what does it say? All right. It means PE equals FH. All right. Those are our 2 formulas. Okay. Now, I'm going to erase this one because we're not going to use it that way. Now, and I'm going to erase this. So we either have this one or we have one of these 2. So if I look back at number 1, again, Logan and William cannot answer. Because I said, when we look at number, they're on mute according to Miss Hudgens. So if I look at number 1, what do I have? It wants mass. So both of these formulas right here, that has mass, this has mass. This doesn't have mass, right? So I know I don't want that. Is this a height or a velocity? So that tells us we want which of these 2 formulas if it's a velocity. The top one, okay? So if I get rid of this, that 10 has to go where the velocity is. So 10 squared. It said what is the mass, so I'm looking for m. Over 2 is a constant. That's not changing. I need KE. What's my KE? So I'm putting 2,565 here. All right. How do I solve? What do I do? Okay. So I'm going to cross multiply there. So if I take my calculator, 2,565 times 2, I get 5,130 equals m times, what do I do with that 10 squared? What's 10 squared? Okay, so I put 100. If I don't know that, how do I do it on my calculator? Does everybody remember how to use the squared key on our calculator? 10. You can say 10, and then you can say up to, or you can say 10, and there's a squared key. It's x squared. You can do it either way, and you're going to get 100 when you do that. Okay, you can do either key, an up caret 2, or you can do the x squared key. Either one. All right, so now what do I do to get m by itself? Divide by 100. M equals 51.3 kilograms. Questions about number 1? Okay. Now, number 2. Notice number 2 is very, very similar. What's the difference in number 2? Tell me what's different about it. Notice again, it has mass, it has a joule, mass, and a joule. It's very similar. Okay?
It has a height and not a velocity.
Okay, see how it says meters? And it said height. Does everybody see that? Okay? Jacob and Alizé said it had a height. Does everybody see the difference? Yes or no?
Yes.
Okay, so if it had a height, let me write out 3 formulas we had back up here again. PE equals MGH or PE equals FH. So when you look at those 3 formulas, which one do we need? Okay? Alizé says this one.
Yeah.
Okay, Sierra's nodding yes. That's right. Because this one has a mass, which they asked for, and it has a height. Okay? So we want mass. We need G, H, and PE. Okay? So, what's our height?
12.
Okay? So I'm going to put 12 where height is. What's G? 9.8. All right, and what's my PE?
1,220.
1,220. Okay? How do I solve for M? What should I do first?
12 times 9.8.
12 times 9.8. That's called combining like terms in math class. Okay, so 17.6. 117.6 times M equals 1220.
117.6 divided by, 120. Yes.
All right, so what do I do now?
Divide.
Whoops. All right, 10.3. Questions about those? Questions about how to do that? Yes or no? You're going to have to do these on a quiz later in the week. Any issues? No? We're going to do some math with it tomorrow. I don't think we'll get to it today. At least I'll be stunned if we do. All right. Whoops, wrong direction. All right, number 3. Determine if the object has kinetic or potential energy. A ball thrown by a pitcher.
Kinetic.
Why?
Because it's moving.
It's moving. A swing pulled back. Potential. It's not moving. All right. Do you still have the work that you did while I was out last Wednesday? If you do, find that, please. I want you to find it because we need to run through some of those examples and make sure we're okay with those. See whose work I need to hand it back. Put it on my laptop and I'll take care of it. Is this paper I'm looking for, by the way? One that looks like this. This one. See what? I have some right around there. Good. I had stuck this in the wrong basket when I handed out papers last week.
Did you get it?
Yeah, it's just stuck somebody else's.
Yes.
Alright. That's all Ashanti's. You. I got one more for you.
Do it have numbers on here, like side numbers, like?
Then chemistry, pass that. Look at the top, it's got dates and days.
Okay.
So you need, if it says 10/15, that's the date, flip back on page. That'll be Fridays.
So this is 8.
That'll be Fridays.
Oh. You talking about the review sheet? Yeah. Yeah.
All right, I only want to talk about the top half because we haven't talked about the bottom half. We're going to do it today. Yeah, I just want to talk about kinetic and potential energy because we've talked about it already. I'm sort of going over it as we get to it. In a minute, I'm going to find a blank one though because I can't find mine, so I have the questions. All right. I go. All right, so number one, kicking the ball. What would that be next week or later this week on the quiz? Would that be kinetic or potential?
Kinetic.
Kinetic. A stretched rubber band between your fingers. Potential. Strike a spring in a watch. That's potential. Okay? The watch dial or the hands or the whatever, most of y'all probably have digital watches. Alright? Does anybody actually have a watch where the hands turn? Okay, if you have that, the hands turning themselves are kinetic. But inside of the watch, there's actually a spring that allows those hands to turn. That spring has potential energy. Because without that spring, the hands would not be able to move. So the spring itself has potential. All right? An arrow flying across a field at a deer. That's kinetic. Because the arrow is doing what? It's moving. A hammer is pulled back to strike a nail. That's potential. Okay? If you've got a hammer here, you're able to strike, that has potential. Shooting a spitball across a room at a friend. Raising a flag on a flagpole. You're raising the flag. That's kinetic. A flag is flying at full staff. That's potential. When I say the flag is flying, where's the flag at? It's already at the top. Okay, so the flag already flying is at the top of the flagpole. That's potential. But if you're raising it and you're actually moving the flag up the pole, that's kinetic because you're actually raising it. The flag is moving up the pole. That's kinetic. But if the flag is already at the top, that's what? That's potential. If it's at the top flying, that's potential energy. But if you're physically raising it and it's moving up the pole, that's kinetic. You see the difference? Okay. All right. So on Friday, we played a clicker game to review various types of energy, right?
Yeah.
All right. Where is it? All right, Jerry, pan these out real quick. Let's see what you remember. Hmm? This is fine. The only thing I'm taking up today is that roller coaster ride.
Oh, man. Oh, wow.
All right. We're going to do this in under 5 minutes. Mm-hmm. All right. What were our 5 types of energy again?
Chemical, nuclear, thermal,
Electromagnetic.
mechanical.
Okay. I heard chemical, thermal, I heard nuclear, I heard electromagnetic. Which one's missing? Chemical. All right. So if we look at number 1, with a waterfall, what kind of energy does it have? All right. Looking at those 5 types. As mechanical, why? It's a motion. Okay. So I want you to use those 5 and write down which one they are. Some of those pictures we used on Friday. Okay. In the flicker game. Okay. We're under 5 minutes. Maybe about 3 minutes. Do all 12. Okay. And then we're going to talk about it. Because we're going to talk about energy conversions between those 5 types. If you don't know, give it your best guess. Okay. It's not bad if you're only stuck on 2.
Rainbows.
Oh, what is that? It's got lights. Is that your charging cord? I've seen one that flashes. Say what?
One of the days.
One day next week?
I don't know yet.
Gotcha. Are you moving next week?
Done.
So what?
With the done.
Oh, okay. Do you know when you're moving?
I talked my dad out.
Oh, you talked your dad out of moving? Oh, okay. He what?
He got family. He moved.
William.
All right. Have we had enough time to try them all? All right.
Yeah.
So what do we think about the waterfall? Mechanical. Smooth. Water moves. That's why it's mechanical. All right. What do we think about lightning?
Electromagnetic.
It is electromagnetic. Okay. Works based on charges. Now, those 2, we can talk about what they start as and what they become also. And we'll talk about that shortly. All right. What'd you put for the baseball player?
Mechanical.
Mechanical. He's moving. All right. The rainbow. Electromagnetic is correct. All right. Anything that involves light is electromagnetic. You may or may not remember this, but rainbows come from sunlight passing through what?
Rain.
Water droplets in the air. All right. The violinist.
Mechanical.
Mechanical. What do we say about all sound? All sound is mechanical. Whether it be our voice, the music you listen to, it is all mechanical. All right. X-rays.
Nuclear. No, electromagnetic.
Electromagnetic.
Oh.
X-rays are electromagnetic. All right. The sun. Nuclear. The sun is nuclear. Okay. Now, that's another one. We're going to talk about the type of change that occurs. All right. Number 8.
Electromagnetic.
Electromagnetic. Okay, we talked about this on Friday. Anybody lose their power
Yeah.
when we had a storm come through?
Oh, strong as ever.
Okay, some people did. I hope you got it back quickly. I have a friend who used to teach with us here, and I don't know how long he's been gone. Did y'all have Mr. Myers? Some of y'all were juniors, so you might have had him. Do y'all remember Mr. Myers? He lost power on Thursday, and he's still without power. He lives in Greensboro.
Sunday morning.
So the Mormon is, yeah, but is he still without power? He's still without power?
I know.
Yeah. I mean, there's some people who are without it. I meant to check to see if Ms. Bostic had gotten hers back because she was without it and she could still be without it. Number 9, with the kite flying in the air.
Mechanical.
Mechanical. What's keeping it up?
When?
Wind. Okay, it's moving. All right, the food on number 10.
Chemical.
Chemical. All right, number 11.
Thermal.
Thermal. A lot of you argue with that one. You picked electromagnetic because it's plugged in and it's electricity. But again, think about its initial purpose. Its initial purpose is to provide heat to dry your hair. But again, we're going to talk about conversions in a minute. And number 12.
Thermal.
A lot of people put thermal for that
What
one.
is thermal?
It's chemical. The candle's burning. All right. However, I would not mark thermal wrong, which is why we're going to talk about conversions. Okay? So we're going to look at 2 kinds of conversions today. All right? First, we're going to talk about these kind of conversions, and then we're going to move into kinetic and potential energy conversions. Try not to break your phone, but at least it's in case. All right. Is yours phone?
It's already broke.
It's already broke. All right. So find your notes if you're going to take it. All right. This first part, I don't even need my slide show because it doesn't require it. All right. So we're going to talk about energy conversions today. We'll probably have to save our math review to tomorrow, but we're going to look at energy conversions today. Now, the first type we're going to look at all right, from one form to another. For example, we could go from chemical to thermal. And the example that you guys just looked at was a candle. Except I'm spelling it wrong. So, how is a candle going to be chemical to thermal? Well, it starts by burning, and if something is burning, it changes into what? It changes into heat, okay? That is an example of an energy conversion. Now, lots of us like to think about cell phones. All right, what does that start as? Okay, it becomes electromagnetic. What does it start as, though? Why? Why? Because it has a what? Battery. Okay, So it starts as chemical and it becomes electromagnetic. Okay? Because it starts as a battery and then it becomes your cell signal. Okay? Batteries run on chemical energy. All batteries, whether they be rechargeable or they be the ones that we just use for a short while and then throw away when they run out, like calculators. Okay? Now, that's one type of energy conversion we're going to talk about today. And we're going to practice that in just a second. The second type, I'll pull up my slideshow so I have the pictures, because I spent a little bit of time drawing those in the slideshow. Okay? All right, we caught up? Yeah? All right. The second type that we're going to do today, and that's what goes with the bottom half here with our lab, is converting kinetic energy to potential energy or potential energy to kinetic energy. Okay? For example, if you threw a ball up and down, you threw a ball up and it came back down, okay? You would change kinetic energy into potential energy. Now, based on the number of views that YouTube video had, virtually no one can tell me where the greatest kinetic energy or the greatest potential energy is. Based on those review sheets, y'all all labeled it wrong. Okay? Now, we're going to talk about where that happens in a few moments. But before we do that, we're going to practice. Does everybody have what they want? We're going to practice this piece first. Okay? And we're going to do that with class flow. And then we'll take some more notes. Okay? Grab your laptop.
No, I got bruise on the back of my leg. I don't know that. I only got 2 hours of sleep. Hey, that's your fault.
I'm gonna bring it. I like party. You got to start off somewhere. They don't even cost $20. Half a year worth. That's it.
Who's up with? Oh, come on.
You want it? You don't want it?
Remember, you're going to classflow.com/student. And remember, y'all's name's not in there. You gotta go to the bottom and type yours in. So I edited the class.
What are we supposed to do?
Go to classflow.com/student. It's up here on the board in black. Google. All right, let me come help you.
Yeah, class flow. Oh, class flow. Google Class. Maybe you need to bow.
/.
Student.
Yeah, you need that. Hit that, it should come up. That's okay. You do what I do. You should not need to do. Yeah, you're not. This is new on the screen. Here we go. No, okay. All right, everybody in? Anybody over here having trouble? Here, see if this will help you in your disrespect to computers. All right. So we're going to see if we can figure out how to do energy types. All right. So It's not wrong. All right. All right, so what kind of energy does it start as? And what kind of energy does it become? Right? What does it start as, and what does it become? Think about what they're doing. What are they doing first, and then what does it become? Okay? It's easiest to type this time instead of trying to write with that stupid mouse. Okay, so pick a text answer. I do not want to spend all day doing this. I want to start the lab. I may not finish the lab, but we need to start it.
I want to start it.
Okay? What does it start as? And what does it become? And then send me what you think. What does it start as? And then what does it become? Okay? Remember what sound is. Okay? That's important. Okay, think about the 5 types.
Okay. Oh, okay.
Does it start as like electromagnetic, mechanical, thermal, and then what does it become? What is it converted into?
Got it.
Got it. Send it up here. Oh, I got a smiley face on that one. All right, I'm gonna hit stop. Send me what you want. Anybody else gonna hit submit? All right, I'm hitting stop. We're gonna check what we got here. All right. Oh, okay. I got electromagnetic to mechanical. All right. I think that's what I just did. I got mechanical to electromagnetic. Mechanical to electromagnetic. Electro to mechanical. Looks like everything I have is mechanical and electromagnetic. I got one here that says chemical. All right, I got a thermal there. Why do we have thermal? They got hot breath? Y'all better not be throwing anything.
One more time, throw something. It's gonna be a wrap. Associated. I need to start.
Who threw something?
I don't know who's doing it, but they need to start.
Now, which one is correct? If you're talking, what type of energy do you start as? Mechanical. And then the signal has to travel through the phone lines. So the phone line would be what? Electromagnetic. So those of you who said mechanical to electromagnetic have the right answer. The other one would be backwards. All right? All right, let's try this one. All right, before I say the poll, look at the candle. Okay? Look at what you got.
It's electric.
All right, it's electric. That's important. Did everybody get the picture? Okay. One of the candles that you can plug in at the holidays. All right? So what's it start as? And what does it become? There's actually more than one answer that could be right here. What does it start as, and what does it become? All right. I'm waiting on a couple. It's what you want me to know. You're getting ready to hit stop. Last call. All right. So we have electromagnetic to thermal, electromagnetic to chemical, electro to thermal, electro to thermal, thermal to chemical, electro to thermal, electro to thermal, thermal to chemical, electro to chemical. Somebody rotated the picture to thermal or to chemical. Electro to thermal, electro to thermal, electro to thermal. All right, those of you who picked chemical, does the candle burn?
No.
No, you're not making any chemicals. It's plugged in. That's why I wanted you to make sure you noticed it's plugged in. So it's not chemical in any form or fashion this time. Okay? Now, the chemical is out. The thermal is fine. All right? The electro is fine. Now, the order is plugged in. So what does it start as? Starts as electro. It does become thermal because it becomes heat. Those answers are fine. Electro to thermal is fine. Now, could you have put electro to electro? Yeah, because it's plugged in, and it also makes what? Light. So you could have said electromagnetic to electromagnetic, which was fine. Okay? Nobody did that. But electro to thermal is fine. The chemical is out. I didn't see anything else that would work that's up here. So I guess that's all we got. All right. Did you get it? Yes, no?
Yeah.
Okay. What do you think that is? Everybody knows what that is, right? I mean, you know what the picture is, correct?
Campfire.
It's a campfire, okay. Just checking. It's hard to do it if you don't know what the picture is of. And John, did that get the goo off your screen?
Yeah.
Okay.
It's a
Say what? Huh? Let me see. Maybe I have the screen too far. No.
They did this last time.
I did it last time too, and I had no idea why. There you go. At least this time I managed to do something to get it fixed, though. All right. Looks like we're waiting on two. The last two people want to put their answer in?
One.
Okay. Stop. All right. So we have chemical to thermal, thermal to chemical, chemical to thermal, thermal to chemical, chemical to thermal, thermal to chemical, chemical to thermal, mechanical to chemical. Chemical to thermal, a blank picture. Chemical to thermal. All right. So if we look at these, we have the mechanical to chemical, it's fine. because they're assuming that we did some work to start it, and then it is chemical because it's burning. This answer is fine. All right. All the rest of them either start as chemical and become thermal, or they're chemical and thermal and they become chemical. So the order's flipped. Which one is right? All right. Why would you say chemical to thermal, Raul? I'll give you a reason. Okay. So that would be what? And then it does what? Produces heat. So it's thermal. That's the order I would put it in also. William.
I said chemical and thermal, but I also said chemical to electromagnetic.
Okay. Why would you say chemical to electromagnetic? Because it puts off light. That is correct. Okay. You could have said chemical to thermal, which is fine. You could have said chemical to electromagnetic, which is also fine, because it is chemical because it's burning and it puts off light, which is fine. Both of those answers are correct. There's nothing wrong with that answer. Okay. Questions? Can you do changes in converting of energy? A lot of these have more than one answer, and there's nothing wrong with them. Okay? Is that okay? All right. Close your laptops right now and set them off to the side. All right? Because the next time you use them, we're going to go into Google Classroom and we're going to do the roller coaster lab. So just close them and stick them off to the side. No one should have them open. Okay? You can set them on a desk in front of you if there's space. You can set them on the lab counter beside you if there's space. All right? You can put them under your desk. But for right now, we're done with them. Now, we need to talk about what you did not watch the other day. Easy on the calculator killer. Mr. Butts can only repair these so many times before they don't work. Yeah, that's what I thought. All right, so we need to talk about how to find maximum potential energy, minimum potential energy, maximum and minimum kinetic energy, and where these things increase and decrease. Now, when we talk about potential energy today, what was the key word that we wrote down for potential energy last week? Anybody remember? What? Height. Okay? So every time we talk about potential energy, here, let me put in a slide. This might make it easier space-wise for me today. All right? Every time we talk about potential energy today, potential energy is about height. Okay? Greater height equals more potential energy. Okay? That's how we figure out whether we have more potential energy or less potential energy. Okay? So in the lab today, when you're looking at it on the computer and you're trying to figure out where the most potential energy is or the least potential energy, you got to look at the roller coaster and figure out where the greatest height is. Okay? So it's going to tell you to click on the grid if the grid's not there, and you look at the grid and you go, oh, where is the roller coaster height-wise? So if the roller coaster has greater height, then it has more potential energy. Does that make sense? All right. Now, kinetic energy is not about height. Kinetic energy is about what? All right. Velocity. What was the other word that we used for velocity that meant the same thing? Speed. Okay? Kinetic energy is about speed or velocity. Now, y'all have all been in cars your whole life. A lot of you have taken driver's ed. Some of you have your driver's license. Some of you may even drive to school. Some of y'all have just been to amusement parks and maybe ridden a roller coaster. Where is the speed of a car going to be the greatest? At the top of a hill, the middle of a hill, or the bottom of a hill?
Middle.
Where?
Bottom.
The bottom. Okay? It is always fastest at the bottom. Oh, it looks a little messed up there. All right? It's always the fastest at the bottom. All right? Whether you're on a roller coaster or you're just driving on a hill. If you've been on a bicycle, you go down a hill. If you take your feet off the pedals and just coast, your speed is always the fastest at the bottom. Not close to the bottom, at the bottom. Okay? Are you with me on that?
Yes.
Okay. Because you're going to have to be able to find the spots on throwing the ball in the air, on a swinging pendulum, on a hill. Where is the greatest potential energy? Where's the greatest kinetic energy? If you can remember greatest height or at the bottom, you can do this every time. Okay? That's the key to this. Now, does everybody have what they want off the board? All right. So if we have rolling down a hill, all right, where is the greatest height? I'm going to number these 1, 2, and 3.
Number 1.
So what would we find at number 1? Okay. So the maximum potential energy is always at number 1.
The same potential.
Okay. So what would I find at the bottom? Okay. The maximum kinetic energy is always at the bottom. Everybody got that? Now, sometimes the state tries to get tricky, and they want minimums. Minimums are just opposites. Okay?
Minimum PE.
Okay? Minimums are just opposites of each other's. Okay? So, if they want a minimum,
Minimum kinetic.
what's the minimum? What's the opposite of that?
Kinetic. Potential.
Minimum what? Now, if you think about it, why would this be the minimum potential energy?
Because it's the greatest kinetic.
It is about height, right? What does this not have down here?
Height.
It doesn't have any height. This is about having the greatest speed, right? What don't we have at the top of a hill?
Speed.
Speed. How many of y'all been to an amusement park? Y'all ever ridden a roller coaster?
Yeah.
No?
Yeah.
I don't either. Have you ever been and watched them? Yes? And you watch the little cars chug up the hill, chug up the hill. They finally get to the very top. What do you know about their speed when they get to the very top? Are they fast or slow is my point. They're really slow. That's why they have the minimum kinetic energy up there, because that's their slowest speed. They're barely moving, okay? But once they get there, what happens?
They drop.
They drop. What pulls them down? Do they have motors to pull them down?
Gravity.
Gravity makes roller coasters move, okay?
Gravity and magnet.
Okay? Now, this is the hard part for most people. You have to know what happens to kinetic and potential energy as the ball rolls down the hill. Okay? What happens as we go down the hill?
Start spinning.
Very good. Tell me why kinetic energy increases, Chase. Because that's exactly what happened. That's right. Okay? Kinetic energy increases. It increases because it speeds up. Okay? As the ball rolls down the hill, that is the exact reason that kinetic energy increases. If something speeds up, kinetic energy increases. Okay? Is anybody with me besides Chase? Because he gave me the right answer. Now, same thing. What happens to potential energy? Okay? Now, what's potential energy about? Height. What happens to our height as we go down this hill? It's decreasing. Potential energy decreases. Why does it decrease? The height goes down. Okay? If it speeds up, kinetic energy does what? If it speeds up, it increases. If the height goes down, it decreases. That's the key to understanding kinetic and potential energy. Virginia, you with me? Hope y'all are when you do the lab. All right. What if we have a ball? Everybody in here watches basketball, probably except me. Okay? Not a fan. Never have been. I know it's a travesty in the state of North Carolina. All right?
That's a crime.
I know. I know it is.
You should go to jail.
I probably should. I'm just not a fan. So, we have 4 positions of a basketball going through a basketball hoop. Same thing. Where is the greatest kinetic energy of the basketball? All right. Greatest kinetic energy. What did we say?
Wow.
Okay.
Potential is 4.
Now, questions about why your classmates gave those answers. Whoops, I wrote KE because I couldn't read my own handwriting now when I was trying to fix it. All right. Where do we say KE was always at? The bottom. Where do we say PE was always at? Questions about that. It never changes. All right. Now, the hard part. What happens here? What happens to KE if we go up? Because the ball is going to do what? Slow down. The ball can't go faster going up in the air. It's got to slow down. All right? But what happens to potential energy as we go up?
Increases.
That's right, because the ball is getting greater height. Now, what happens here?
PE decreases.
All right, PE will decrease.
And KE increases.
KE will increase. Now, why does PE decrease?
Because you have less height.
There's less height. Why does KE increase?
More
It's going faster. All right, the people who are answering have it. What about those of you who aren't saying anything? Yes, no? All right, what if we do this one? All right. I got to draw some ugly cars. Let me put him. Oops. Let me put my roller coaster back together here.
Wow. Big gap right there.
All right, let's number them 1, 2, 3, 4, 5. Let's say the cars go.
But they look like they're going the wrong way.
I told you can't draw. They're going that way. Okay? Where's the greatest potential energy? Which car has the most potential energy?
The first one.
2 has the greatest PE and 4 has the greatest KE.
All right. Why does 4 have the greatest PE?
It's at the bottom.
It's at the top. Okay? Greatest PE is always at the top. So that's why it's 2. All right. Who has the greatest KE?
4.
All right. Why does 4 have the greatest KE?
Bottom.
It's at the bottom. Okay? Questions about those? It never changes. All 3 pictures. Greatest height was KE, or PE rather. Bottom was KE. All right? So, somewhere on here, tell me where KE is increasing. Where would KE be increasing on those arrows? Give me a car number where kinetic energy is increasing.
3.
All right? Kinetic energy is increasing here. Why is kinetic energy increasing there?
Going down.
It's going down.
Number 1.
All right. Give me a spot where PE is increasing.
1 and 5.
Okay, PE is increasing here. All right, and PE is increasing here.
Because it's going up.
That's right. We can't really say a lot there or there because they're sort of flat. Okay? All right, last one. What can you tell me about this? Is a pendulum, something swinging back and forth. You might see it in a grandfather clock. You might see it on a playground if you were sitting on a swing. Okay? You could say something to just swing it back and forth. If you've ever seen somebody pretend to hypnotize somebody, you might see this also. All right, where would we have the greatest PE?
1 and 5.
Okay, a maximum PE. Maximum PE. All right, where would we have the greatest kinetic energy?
3.
All right, where would PE increase?
4.
Okay. Where would KE increase?
2.
Oops. All right, tell me this. Where would the velocity equal 0? Why? Got all those cylinders firing today, Chase. That is very good. All right, velocity equals 0 at 1 and 5. If you look at a swing, what happens? Everybody's been on a swing before. You get to that point, you stop instantaneously,
And then
you
go
swing back the other direction. You stop, you swing back the other direction, you stop, you swing back the other direction, and you stop. Velocity equals 0 for a split second before you change directions. That's why velocity is equal to 0 at 1 and 5. Questions? It's nice to have you participate today. Thank you. All right, questions? You think you can do this?
Yeah.
All right, let's talk lab.
Yeah.
All right, I'm going to have Jacob hand this out to you. All right, this one's on the Chromebook. You're going to have to go into Google Classroom to get the link, though. Okay? It's really an on-your-own kind of lab. It's not one that requires a group or a partner.
But can we have a partner?
You don't really need a partner,
Can we have one?
I suppose.
Yeah.
Right down over here.
Yeah, I got a little all the way over there.
And we should be able to finish this by the bell, because this is pretty short. Now, when you go into Google Classroom, you're going to need to go pretty close to the bottom of the list. It's not all the way at the bottom, but it's close to the bottom. Maybe 4 or 5 from the very bottom of the
That
list.
boy, dang it.
So this means you won't be out to US, okay? So we're good on that, right? And then you'll read the lesson teach after today, right? Okay. Make this. Put it back to the door.
Wait, what did you talk?
Roller coaster lab, I think. I labeled it last week. I think it's called roller coaster lab.
No, it's not. It's called like skater park.
It's called what?
It's a skater park.
Skate park.
Skate park?
Skate park. I don't remember, I labeled it last week. Sports box. Oh. You should think, yeah, right
I
there.
was like, oh.
And Tuesday is the only day I have this week. Yeah, next week's a better week, but I've got tomorrow if you've got off. Okay. Here, close that thing so we can see. Go there. Right, scroll down.
She's on one way for you right now.
Keep going. There it is. Back up just slightly. Skate park. It's called skate park energy conversion. John and John. The first John is still on class flow. The one that I can see. get to Google Classroom and the site you need, or you can work by yourselves in a chair. And those of you who are sitting at a counter, please don't mess with any of the equipment or accidentally knock it over. Huh? Fabulous. Then you should be able to operate this and answer my questions.
Mr. Walker?
Yes,
You very quick.
sure.
Okay. Hey, you mind? Going over there real quick?
And Sacramento, stop submitting stuff that doesn't require submitting.
Yeah, Sacramento.
Yeah, follow the link. All the way down here.
Yes. Keep going. Keep going. Just keep going up. No, I mean, it's down here.
Hey, look.
Keep scrolling. Okay. You've not joined yet.
Ugly.
Today's the 15th. What?
They got broke my
I
glass.
don't know what you want me to tell you.
Your glasses was already broken.
They break it in crowds.
Boy, you ain't blind. You ain't blind? Yes? Nah, these. These look like my normal vision without my glasses.
There you go.
All right, who else is not in Google Classroom? Everybody there?
Yeah. Hey, where do I go?
On the skate park lab.
Is it
Where do I
Rose?
go? Well,
No, it's just big. No. It's like right
You see
here.
how I clicked on that?
Where's that?
Google Classroom.
oh,
No, go down to the bottom, and you're looking for where it has skate park. Skate park, yes. Don't click there, there, click the link there, yes.
so you're telling me that I can make.
Go up here. And then- Anybody else not there? Y'all there? Now, follow the directions on the lab sheet. Do what it tells you to do.
Can you come here, please?
Is it a piece of plastic? What kind of chair? Yeah, Christian?
John and John, work. All right, everybody doing okay? Yep. So I'm asking you. There's something on there and something we talked about last week that should answer that for you. Ask Lucia. I'm not going to tell you. Yeah. Gonna sing the Saturday at the fair. I could barely bend my fingers Saturday.
So do it tell us the speed or something when we do it, or we gotta figure it out?
You don't need to speak.
Not the speed, but like the.
Where you at?
That's kind of what I said to you.
Yeah. Why do you need to speak?
No, I was saying, I don't need the speed, I'm saying
Yeah.
like,
Yeah, but what are you doing on here that makes you think that you need the speed or something? Well, I didn't say erase that. I'm just asking you what on the lab makes you think that you need the speed button, or it needs to know the speed, that's what I'm asking.
No, I don't need to know speed, I'm just saying like, I don't know how to, if I'm doing it right.
I don't know if you're doing it right either. Does it stay the same, does it change? There's a bar graph on there that tells you about total energy. See how energy is there? Or is it total? See if it changes or stays the same.
Yeah, they should go down.
What time does that again?
Yeah, it's done. It's on my laptop.
Oh, we need to go again.
What you mean, click on the bar?
All right, see these little gray boxes that are right here? Why is this not going out? I think it's supposed to all be out. I told it to log in. One sign on it. That's good. I also don't want it in my Google. It's got all those things up there. So when we go to classroom. I guess it's just gonna be there. You good?
I think no.
Yeah, just wait on my computer. All right, type in your Google and password. You don't have a school? You're supposed to have a school email and a school. What's your first four letters, dot, first four letters of your first name, dot, first four letters of your last name? Everybody's getting one, you have one. All right, so it's the first four letters of your first name. Dot, the first four letters of your last name. Then what is it, your lunch, four numbers of your, hey, Alexis, what is it? First four letters of your first name.
The last four letters of your last name. Yeah, like your last name.
Last four letters or the first four letters?
The last.
Is the last? I swore it was the first four. When you type in your.
It's the first.
It's the first
Oh,
four.
okay.
And then what is it of your lunch number? The last four of your lunch number. Last four of your lunch
Oh,
number.
yeah, there you
And Lucy. And then what is it after that? At LEX. At student dot LEX. Yes. Which is
Right, bro. That's gonna be amazing.
and then
Bro,
and your password is your lunch number.
Well,
How does that go?
not for real. Okay,
We
leave
need to
it.
go back.
Your whole lunch. Yeah, they didn't change your lunch number? Why? Because I don't want what you got. No offense. If you don't feel good, I don't want it. Doesn't mean you don't have something else. It's different, it's whatnot. Which administrator is in charge of sophomores? I want to say it's Harvey. I'm pretty sure it's Harvey. Because Ms. Curry's in charge of juniors. And if we have to wait on Ms. Curry, we'll be. She's just always busy. I would think so. Oh, all three of them? It's gonna be a full room. Because I know this Cross, Mr. Zelman, and I are gonna be there. I know this Cross, me and Mr. Zelman are gonna be there. And I'm sure one of them will be there. At least I'll be surprised if they're not. They're that too. I don't have anything to do with that, 'cause I wasn't here. My lesson plans. All right. You know Miss Floyd? She's at the media center. She's the media specialist, and I'm not sure you can take. You're like, well, all right, take the desk, take this laptop, go see Miss Floyd media center, see if she can get you logged up. You know, like you're gonna be spied on by international spies. I'm sure no one's been spying on you, right? The government's not checking you out. At least not today.
Oh, yeah, but I can't do
Thank you, Vince.
Yeah.